Okay, cool. I'm gonna share my screen. I totally did not understand. So like, for 22, I got 4.499, but you can't even put that in the normal probability applet because it only goes to 4.
What'd you get for 21?
21, I got it wrong. I also got 20 wrong, and 19. I don't understand how to do 19, 20, or 21 either.
Okay, so I got
Or 18.
21 and 22, right? I'm not really sure how I did it. I kind of worked backwards. Like, I'm gonna try to explain it and see if it makes any sense to you. But because it says that 1.59 equals u minus 2 or whatever, 2 standard deviations. So that was 1.59 at the 2 standard deviation, right? At the negative 2 standard deviation. And then 2.52 at the 2 standard deviation. And so then somehow or another, I just kind of figured out the distance between them two. And I divided that by 2. I really don't know how I did it, but I got it.
Yeah, I was like, for not understand.
Yeah.
No. Also, I got. What'd you get for 18?
For 18, oh, you know what I think it is? I think it's 50. Because I put 75, thinking that it covers until the third quartile. What is it called? Quartile?
Yeah.
But I forgot that, like, there's the first one, the first quartile's missing.
This is the first quartile.
Mm-hmm. Well, that's the second. No, wait. That's the first one.
This is the median, and then this is the third. The way I did
75, but I just don't know because I didn't know.
Yeah, the way I did it is I just took like 2 to 12 is 10, right? And then I did 4 divided by 10 because there's 4. Because it said between 4 hours and 8 hours. Thank you very much.
Yeah.
Very strong. Is it? So I don't know.
I put that it was 75% because I thought until the third quartile, but I don't know.
Well,
did you get the sample? I mean, the sample ones? Because I just didn't even know what was going on there.
Yeah. All the sample ones except for the last one. I was a little confused on it. Because it says, what does it say? The researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of the registered Republicans and selected a simple random sample of 100 people. Which sampling scheme was implemented? Simple random sample, right? But no, I got it wrong.
I put stratified.
Did you get it right?
Yeah.
So why do you think it's stratified? Because stratified, that's the one that's
Oh, because it divided the Democrats and the Republicans, and then it took 100 from each.
Oh. Okay. That makes sense.
But I got number 4 and 5 wrong because I don't understand.
So 4 is also a stratified sample because it's the same concept as number 8. Because it says our neighborhood has very low property values and another has extremely high property values. What type of sample should we collect? What type of sample should we collect to gauge the response? So they should divide them into low and high, and then take.
Random ones from each.
Yeah.
Oh, okay.
And then 5.
And then 5, yeah.
5 is a cluster because so it says researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in selected classes. So if you go back and look at the cluster, it says all items in one or more randomly selected clusters or blocks. So like they chose a particular district. So that's like a cluster. And then they randomly selected 4th grade students or 4th grade teachers and then tested everybody in those classes. Does that make sense?
Yeah.
So a cluster sim is all items in one or more. So that's what got it, was all items, because all the students in the randomly selected classes were taken samples of. That makes sense.
Yeah.
Okay, so for number 10, it says, I created a histogram representing the amounts. The histogram, isn't that just what's on this Microsoft?
Yeah.
Okay. It like makes the histogram for you.
Mm-hmm.
Also, 13, how come it's not the variance?
I got that one wrong, but I put standard deviation, so it's either it's either mean or none of these is correct.
Okay, I think it's none of these is correct because I don't think that it's the mean.
No.
Because I was definitely looking at the book and I was like, okay, like I found the lesson where they did that, but it didn't. Oh, you want to know why I put standard or variance? Lesson was that 4 or 3? Maybe it was this one.
It's that one, I think. Yeah.
So the standard deviation is, see, it says variance right here.
Oh.
But variance is wrong, and so is standard deviation.
Mm-hmm.
So I don't know.
But it's definitely not mean.
Yeah,
Right?
I don't think so. Well, I don't know. That makes me like second guess now. Oh no, wait.
Because right here it has sum equals u. Isn't u mean?
It says the fact that the mean is 0, 4, and that's the mean right here. Oh, I forget that you can't see my fingers. Here. I'm pointing at my screen with my finger. But yeah, so like, and that says mean. Maybe it is mean.
But
Is that?
huh.
Well, wait a second. This is the mean. This is what they're talking about. Wait, go back to the question. The squared deviations column. Oh, that's not the one I wanted. So the squared deviations column would be this column, right?
Oh, okay. Yeah.
So then, yeah, I don't think it's the mean. Just kidding. Take that back. Erase. Yeah, I think it would be none of the above. Because I don't think. Okay, cool. So, well, then let's just start the quiz again, and then once we get down to those lower questions, we can just work them out.
Right.
Because kind of confusing. Where is it? This one? Huh. Okay, so true.
Oh my gosh, that's why I got that one wrong. How'd you get 100 as a parameter?
So I looked it up. I looked up the definition of parameter, and I looked at let's see. I found it in here. So it says a parameter is a true but usually unknown number that describes a population, and a statistic is an estimate of a parameter obtained from a sample. So 100 is the parameter because that's like from the US, and then 112 is the statistics because that's the mean of the scores that they randomly selected.
Okay. That's interesting.
I know. I was like, am I supposed to pick 2 or?
Yeah.
But I picked 2, and I was like hoping that
that it was right. Oh, that's funny. Okay.
because it says which of the following statements.
Oh, tricky.
Maybe I should pick 2 because I almost only picked this one, but then I was like, wait a second, this one's also true.
Yeah. Well, I didn't even read it right, I think that's why. Because I just read 20 randomly and I was like, oh, 20. And when I didn't see 20 on there, okay, that makes sense.
That's funny. Okay. So I kind of want to go through these ones again and like not look at until we like come on and answer.
Okay.
That way, like really understand it.
Mm-hmm.
If you want, you can move Haley's computer so you can come up there and sit. I will. So I made like a little study setup, my roommate and I, because yeah.
That's fine.
Okay. The property values are similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Oh, this one's the stratified.
Mm-hmm.
Because you want to do opposite. So
You want to take from both the high end, right, and the...
Yeah. So stratified, the definition is like splitting them into groups and then randomly taking samples from those, right?
Mm-hmm.
Okay.
Yeah, that makes more sense now.
Okay. When designed experiments are conducted in a public school systems, researchers typically choose a particular district and randomly select teachers of safe first grade students in that district. So they pick a district and then they randomly choose fourth grade teachers and then they take all the kids in those random. That would be cluster because cluster tests everybody involved in that random sample. At a school fundraiser, the name of every person who attended was entered into a prize. This one's simple random. Just because everybody was involved.
Mm-hmm.
So this is the one I got wrong, and you said it was stratified, right?
Yeah.
Because they split it into Democrats and Republicans.
Mm-hmm. And then take 100 from each.
Okay. Okay, so for this one, you don't really need to redo. I just feel like those sample questions really get me every time. Like I have to read through them 5 or 6 times before I really understand them.
Yeah.
Also, did we ever email our teacher about
I don't think so.
I did not. I forgot.
I do not either.
What was that?
I didn't either.
Oh. Yeah, we should probably email her. Because I feel bad. Like, he's not responding to any of my emails anymore. 4.771. Did you get 4.771?
Yes.
Okay. And then 1.912.
Yeah.
True. Okay. And this one, negative 0.165.
Yeah. Okay.
And then 12 was 0.681. Okay, and then this is the one. So none of these are correct.
Yeah.
That one.
Otherwise, we know for sure it's the mean.
That's true.
The standard deviation. But I don't think so. Yeah, that's just weird.
Okay, so I got this one wrong. What is the standard deviation of these temperatures? That's when you do all of these, right? And then you add them together, and then you take the square root of it.
We have to subtract 1 first, and then take the square root of it.
What?
Yeah.
Wait, why do
So
we have
you subtract, you take the number of samples and you subtract 1 and then square root it.
Do you always subtract 1? 1 is always the number you subtract?
Yeah. You always subtract 1 from the sample size.
From the sample size?
Yeah.
Wait a second. Okay, so you're saying we do the math for this, right?
Mm-hmm.
Add it up. Then you do 4 minus 1, which is 3.
Mm-hmm.
And then what?
And then you divide it, right?
You do 3 divided by the square root of the sum of those?
Let me. I just went off of the formula. Where? Oh, okay. I wrote it here. Okay, so you take the sum, then divide by the sample size minus 1. So you take the sum divided by 3 in this case, and then you square root your answer. So whatever was the sum.
Did you get this one right?
Yeah.
Okay, so I'm trusting you.
Yeah, but I think it's a little bit more up.
A little bit more up?
Yeah, on that. Mm-hmm. Is this a lesson or is it lesson 3? Maybe you're right. Maybe it's lesson 3.
This is lesson 3.
Oh. Oh, yeah. Okay. I think further up.
No, you're right. So you do 1 minus the sample number. 1 minus the sample number or the sample minus 1?
The sample minus 1.
Oh, that just says numbered 1 through 59. Pfft, they can't do that to me. That looks like a negative sign.
Oh, that's funny.
Okay. Maybe it's up a little bit more.
Yeah, I think so.
But it says finding the standard deviation.
But I think it's the one where it said finding the standard deviation by hand or something. Yeah, I don't think it's in this one. I think it's in...
Is it 2? Oh, wait, this is lesson 4. What the?
Oh, yeah. So I think it's lesson 3.
Yep. Calculating standard deviation by hand.
Yeah, there you go.
Okay. So we complete that column. So I've completed the column. So yeah, so 4 minus 1, which is 3.
Yeah. So step number 5, divide the sum.
So what is the sample variance? The sample variance is 3? 4 minus 1 is...
after you divided the sum minus the 3 is the sample variance.
Oh, divide the sum of the squared deviations. Oh, wait a second. So let me This class is, oh my goodness. So the numbers I got, that's wrong. So when I added them all up, I got 1.5341.
Mm-hmm.
Am I supposed to square that?
No, because that's already squared.
It's already squared.
Mm-hmm.
So I do that number divided by 3.
Yeah.
One 1.5341 divided by 3. 0.511.
Mm-hmm. And then you take the square root of that.
Oh. .715.
Yeah.
Okay, I need to write that down. So this is the standard deviation, right? Standard deviation equals. How can I write that? So I'll just put sum squared divided by n minus 1 equals
And then,
answer, and then square root it.
yeah.
That makes a whole lot more sense.
Yeah.
So 0.715.
Mm-hmm.
Okay, under certain conditions, no, it cannot be negative. Extradural. Okay. The third quartile.
So that one was 8, right?
Yeah. So now we need to figure out how to do this one. The percentage of the data.
Is it on that same one?
Percentiles and quartiles.
Yeah.
So I wish it would show us with an actual box plot though. Like, how do we find, it doesn't show us how to find
The actual.
the percent from it.
Okay, let's see. Hmm.
Maybe we have to do something with like the first percentile and because the third quartile is what, 75%?
Yeah, and so that's what I put, thinking,
Maybe we have to do something with the first quartile and the third quartile because that's where it says 4 to 8. So quartile 1, median, quartile 3.
So quartile 1 to quartile 2 is 25. I really do think it's 50. Because quartile 1 to quartile 2, that's technically quartile, so that's 25, right? And then quartile 2 to quartile 3 is another 25.
But it says what percentage of the data lies between 4 and 8 hours? And
Yeah, so 50%.
is it talking about the whole thing though, like from here to here?
Because if that were the case, let's see, 2, 4, 6, 8, 10, 12. 2 to 12.
Is 10.
Because would that mean it's 30?
I don't know. I mean, yours does make sense.
Yeah.
But I'm just not sure if it's like, because it says
What percentage of the data moves between 4 hours and 8 hours? I don't know. That was a tricky one. I just don't remember ever reading anything about that.
Yeah, I don't either. But yours does make sense because it lies between, and if this is quartile 1 to quartile 2, that's 25%.
Mm-hmm.
And then that's 25%. Well, should we just put 50?
I don't know.
I don't know.
And then it talks there about, but that's percentile. I mean, the first quartile or 25th percentile.
Like, there's no way that we could do something like this, though, because it doesn't give us enough information.
Yeah. Hmm.
Do you want to just go with 50?
We can go with 50. For the best.
All right. This one, I don't even know how to begin it.
Okay. So I just kind of drew it. So I drew 1.159 at 2 standard deviations, and then 2.52 at the other. The first one was at -2, and then the other one at +2. And then between those, there's a distance of 0.93.
So you put, can you hold your drawing up to the computer? Or to the
My drawing is this little tiny thing right here. Can you see it? Hold on. You can't even see it.
No. Okay. So you're saying you put 1.59 at one end. So like 1.59 and then 2.52 at the other end.
Mm-hmm.
Okay. And then
I subtracted the 2.52 from the 1.59 to find the distance between them.
is it positive or negative?
It would be positive.
So you did 2.52 minus 1.59 equals 0.93.
Mm-hmm.
So what is that 0.93? That's just the distance.
Yeah. And then I really don't know how I did it, but I got it right. Because then what I did is I divided that 0.93 to find the first standard deviation.
You divided it by what?
By 2.
Why?
Because since it's at 2 standard deviation, I want to get 1 standard deviation.
Oh. Okay. So then you got, so that's 2 standard deviations. And 0.465 is 1 standard deviation?
Mm-hmm. So I subtracted a 2.52 by that. I just don't know. Because what I got as the mean is 2.055. And that was right. But now that I'm saying this out loud, if I did the 0.93 divided by 2, and then subtracted 2.52 from that, yeah. have no idea, honestly, how I did it.
Because what's mu? So, like, what did you put in your equation? So, like, we will assume mu minus 2 sigma equals 1.59.
Mm-hmm.
Estimate.
But I didn't. I just guesstimated. Because I ended up getting that the standard deviation was 0.233. And that the mean was 2.055.
So then.
But then did I divide 0.93 by 4? Yeah. So that's what I did.
By 4? Why would you divide it by 4?
I don't know. Because I guess I count, but that's 3, because there's one standard deviation, then from one standard deviation to the mean, that's 2, then the mean to the first standard deviation, that's 3, and then back to the second deviation. I don't know, Ashley.
I am not catching. Okay, where was this in the lessons? Do we know?
I don't know.
Like, I don't remember doing a question like this. Would it have been finding the... No, it's not the probability. We're not doing a probability question, are we? We're doing a mean question.
Yeah. Okay, so let me, can you see that one? Kind of.
Hang on. It's like the screen is off.
Oh.
Kind of, but it's not clear.
Oh my gosh.
Like, I can't see the numbers, but I can see, like...
Kind of the gist of it.
Yeah.
So here's the 1.59 right okay. Here.
Yeah.
And then here's the 2.52.
Okay.
And so then this whole thing is 0.93. And then I divided 4 because from here to here, that's 1, 2, 3, 4. It worked out. I think I saw a video about it, but I don't remember which lesson it was.
I'm not getting the 4. That's the part that I'm not getting.
From the -2 standard deviation to -1, that's 1. And then -1 to the mean, that's 2. The mean to +1, that's 3. And then 1 to +2, that's the 4.
Oh, like in the probability applet? Is that what you're
Yeah, like on that. So I took the 0.93, the distance from the one end to the other end, and divided it by that 4 to figure out what it would be at -1, and then the mean, and then +1. Does that make sense?
Yes. Maybe.
Mm-hmm.
Okay. So, excuse me. You did 0.93 divided by 4 equals 0.2325.
Yeah. So that was my standard deviation.
Okay.
And then where it asked me for the mean, I just subtracted 2.52.
Or yeah.
Or whichever way you want to go.
minus 4.65.
What did you say?
Minus 4.65.
Yeah.
I mean, that totally makes sense, but like, what if we have another question like that where it's, are we gonna know to divide by?
Yeah, because I don't remember that either. I want to say I watched a video and something similar like this, but I'm
Like,
not
what,
even sure.
a situation where we divide by 2 instead? Or did you do -2 to negative, or to -2 to +2? That's what you
And
did,
that's
right?
why I did 4. But I mean, I guess if it's -1 and then +1, would that be 3? Like, or just 2? That would be just 2 in that case.
Yeah, it would be just 2. Okay.
Goodness gracious. I don't know about that one.
I'm proud of you for getting the right answer, though. So then the next one, estimate the standard deviation. That's the 0.233.
Yeah.
Right?
Yeah. For the mean, what'd you get?
2.055.
Oh, okay. Okay, yeah.
Okay, did you get this one right?
Yeah. So it's the last one.
Why?
Because I subtracted the 2.52 from that 0.232 or 2.233.
So you did 2.33 minus 2.52?
No, 2.52 minus
Oh.
0.233. And then 1.59 plus 0.233.
Oh, that's why we got, wait. So, oh, wait a second. Wouldn't you do 2.055 plus 2 times that? Oh, no, wait.
You could do 2.055 plus 0.233 since we know the mean. I just wasn't sure about the mean.
So for that one, you can do 2.05
Yeah.
plus,
Yeah, we already had that.
and that is 2.8. Oh, okay, that makes sense. And then you did or did you do the 1.5? No, you
I
did.
think I did the 1.59 and added, but you could do the 2.055 and subtract either way.
Okay, that makes sense. Okay. This is where I just did not understand. Okay. I feel like I say that a lot. So what did I do? Where's my work? Okay. So I did the 542.3, which is the mean, divided by the standard deviation. Am I missing something?
Then you took the standard deviation and you put it in, you took the C-score and put it in the applet, right?
Yeah, because the z-score is just the mean divided by the standard deviation, right?
Mm-hmm.
So for the z-score, I got 4.499. Is that what you got?
No.
No?
Mm-mm. But because I did the 542.3 minus the mean and then divided by the standard deviation.
But the 542.3 is the mean.
I don't know. Hold on. Oh, snap.
I don't know why this is so hard because I definitely got a really good quiz grade on my homework the other night. So I like don't understand what I'm doing wrong.
Okay, but how'd you get 4?
Because I divided 542.3 by 120.54.
Okay, this one's a tricky question. I remember this one now. So you do have to subtract it because it's at 0. Because it's the mean.
What's at 0?
The z-score. Because that's the mean.
What?
Because the mean is always 0, right?
When did we learn that? Oh my gosh.
Oh goodness. Because remember, the standard deviation is how far away it is from the mean.
Yes.
So if 542.3 is the mean, then it's at 0. Does that make sense?
No. No, it doesn't make sense.
Okay.
Because so the standard deviation is how far away
it is from the mean.
So 120.5 is how far it is away from 542?
No, 542.3 is the mean itself.
Yes.
Yeah. So since it's the mean, it's at 0 on the whole z-score.
Okay.
Right?
Yes.
So on the normal probability applet, yeah. Maybe if you look at the normal probability applet.
Okay. This is what I tried to do earlier with my it gave me.
Oh my gosh.
I was like,
because you have to subtract the 542.3 from the 542.3, regardless. Because the 542.3 is the value they're giving you.
oh. That's why it's 0.
Yes.
Okay.
Right?
Yeah. Okay.
Getting it? Okay. So then once you put it into the normal probability applet, you have to highlight over. I mean, but if it's at 0, it's going to be 50%.
Yeah.
Right?
Yeah.
Yeah, but you have to put that 542.3 into the formula, even though it's the mean, because that's the sample value they gave you.
Okay. So then the z-score is 0?
The z-score is 0. So then you put it in.
Because you do 542 minus 542 divided by 120, which is 0.
Mm-hmm. And it gives you 0. And then you have to plug it into that applet.
Okay. Did I get that one right? I swear I put 0 in for that. No.
But then you have to put it into the applet so it'll give you the area probability.
Oh. So it's 1.
No, it's 0.5.
What?
Because it's asking you above.
Oh.
Yeah.
Okay. Okay. We'll score above. Okay, I understand. Yeah. Let me write this down. 542. Oh man, I'm struggling. 542.3 minus 542.3 divided by 120.54 equals 0. And put probability applet above.
Mm-hmm.
Okay. What is the probability that a selected student will score below 600? So this is where you do 600 minus 542, right?
Mm-hmm.
Okay. Now I'm catching on. I think the first one just threw me off because it was 542 minus 542.
Yeah, it threw me off too, and I was like, wait, that doesn't make sense because I kept on typing into the calculator, and it's like, it's 0. I knew in my head, but I'm like, how could it be 0?
Yeah. What? Oh my gosh. Okay, so 57.7 divided by 120.4.
120.54. Mm-hmm.
54. You're so right. So then you get 0.479, right?
Mm-hmm.
And then you put that into the probability applet, right?
Right.
0.479. And then you do above. So it's 0.316.
But it wants below.
Oh, once below.
Yeah.
So all of this.
I can't see your screen.
Oh, I unshared it because it was doing weird things when you were trying to show me your drawing. Like that?
Yeah, like that.
So it's 0.684.
Mm-hmm.
Cool, cool. Okay. We'll score above. We'll score 600 or above. So now you just do this part, right? That's
Yeah.
okay. Oh my gosh, percentiles.
Mm-hmm.
Find the GMAT score that corresponds to the 10th percentile. Okay, so how do we do this one?
Okay.
Definitely do
Okay,
not.
so you go to the applet first.
So I'm at the applet.
And you put 0.1 in the area. Because that's the 10th percentile.
I'm watching a video on this.
And then 1.282. And then in this one, it's the negative 1.282. Because remember, it was like if it's in the lower percentile or something. Oh, because it's supposed to be highlighted on the other side. That's why. But whatevs. It works.
Wait, no.
Hold on. Okay, let's erase the blue and then just put enter on the, because it's supposed to be highlighted only to the
Left.
yeah, there you go, that side.
This side.
Yeah, to the left of the red line of the other red line. Oh my gosh, I'm struggling. Yeah, right there too.
Okay, right here too.
Mm-hmm. And then put 0.1.
0.1.
Mm-hmm. Okay. So that's your answer.
So
negative 1.282.
Drop my popcorn. Negative 0.282. 1.282.
Negative 1.282 equals x minus 542.3. Because we're going to solve for x now.
Equals what?
The mean, or no, not the mean, the x value.
So x minus
the mean, the 542.3.
Okay. Divided by
the 120.54.
This is making so much sense. Okay. I don't think you were like, I had a friend over the other day when I texted you one question.
Mm-hmm.
I was like, stewing on it forever. And I was like, she's not texting back. Like, and I
oh my gosh.
it out, and you texted me, and you're like, I haven't looked at it yet. And I was like, I was so excited. My friend probably thought I was the craziest person on the world, but
that's so funny.
I figured it out.
That's a milestone right there.
Right?
These things are crazy.
I know. Oh my goodness. Okay, so then we do back to simple math.
Mm-hmm.
Okay. So we do both sides times 120. That's what we do.
Yeah.
Right?
120.54. Mm-hmm.
2 negative times 120.54 equals negative 154.53228. Okay, equals x minus 542.3. And then we just add
542.3.
2.3 equals. So x equals 387.
Yeah, 387.7, and then you have to round.
So it's 388.
Mm-hmm.
Wait a second. Oh, that's the score. Yeah. Okay.
Yeah.
388. I was like 10th percentile. It's supposed to be a percentile. 388 is not a percent. It is so late, and I'm like, I don't math when it's or early. It's like you can't find a happy medium.
So funny.
Okay, so now it would be 90, right? So you do 0.9.
Mm-hmm.
But it should be this that's highlighted, right? 0.9. Oh, all of that. So do you just do the positive point?
Yeah.
Or the 1.2?
Mm-hmm.
Okay. So then it would just be a positive 154.53228, right?
Uh-huh.
154. And then you add 542.3 equals. So the other score would be 697.
Mm-hmm. 697.
Find the first quartile. So 25%.
Mm-hmm.
Okay, so now how do we do that one? We get 0.25 up here?
Yeah, 0.25. But you have to, I really don't know. I just remember them saying it has to be marked to the left-hand side.
What if I just put 0.25 in here and okay. Never mind. That did not work.
Is Rachel here?
Yeah, she's on the floor.
Oh, she was like invisible.
Oh. Okay. Let's see. So, what was she saying?
Move the popcorn thing off my laptop. Just gonna grab it and you can set it back down.
Can
we close the door?
Yes, please. So what did she say? Is it below 50 or below?
Yes, that's why. Yeah, below 50, then that's when it's a negative.
So would I highlight both of these?
Yeah.
25%?
Mm-hmm.
I know I was so mad when we got that question wrong. So negative 0.74. Okay. Negative 0.674 equals x. Same thing, right? X minus 542.3 divided by 120.4554. 54? Yes.
54.
Okay. So then 0.674 times 120.54 equals negative 81.24396 equals x minus 542.3 And you just add 542. So 461. What you got? Yeah, 461.
Yeah.
Okay, now we do it with 75%. So now I highlight just this side, right? Or both these. Oh, it's the same thing?
Mm-hmm.
Okay. That makes
So
sense.
the 25 plus the 75. But I'm wondering if like there's an easier way than to have to do the math.
620 through 4? 624?
624, yeah.
I don't know why none of this made sense to me before like a couple minutes ago. I swear, we haven't done any questions like these percentile ones. Or maybe we have and I just all there.
I think we did like one or two maybe. And it was the one that one of them we got wrong.
Oh,
you remember?
yeah.
But
That
I
was
think
so,
that's the only one we've done.
I think so because whatever. Anyways, consider a simple random sample. What does it mean? Oh, is this is when we do, okay. Don't tell me, I want to figure this out.
Mm-hmm.
What is the mean of the distribution of sample means for all essentially most? So we have to, this is the one where you do like x minus 542.3 divided by 120.4 divided by the square root of 15.
No.
15 divided by the square root of 120.
No, it's asking for the mean.
What? Oh, is
So
that
what's the mean?
I don't know. Okay. I'm not. Nope. Tell me.
Read the question again. Hold on. But you have to read like where it talked about everything.
Consider a simple random sample of 15 students. What
But,
is
like,
the
yeah.
mean?
You have to go back up to where there, right there, right there, right there.
So 15 students. What is the mean? You have to do
The mean always stays the same.
right. So this is the mean.
Yeah.
Oh, it's 5.3.
Yeah, that's it.
That's it?
Yeah, that's the mean.
I hate questions like that. Oh my gosh.
That's so funny.
We did this last time. We did a quiz and you were like, yeah, it's just that number. And I'm like, what? What? Okay. What is the standard deviation? This is the one. Reduce 15. Okay. So, but wouldn't it just be 0?
No.
Well, why not?
Because you're doing the standard deviation by the sample mean, the 15.
Right.
So what's the standard deviation again?
120.54.
Divided by square root of.
Oh. So you don't have to do the whole like minus. What is that for? You know
Which one?
Z-score. Never mind. Right?
Oh.
That's the Z-score. Where you
Yeah,
do,
when you do x minus mean over standard deviation.
yes.
Yeah. But this is just asking for the standard deviation itself.
Okay. So then so this is one where it's 120.54 divided by square root of 15. Okay. Let's see. 120.54 divided by. 31? Is that what you got?
31.123.
Mm-hmm.
Mm-hmm.
I'm always like nervous about doing it in my calculator and not breaking it down, like doing just the square root of 15 and then like writing it out and then doing one.
Mm-hmm.
I'm not gonna do it right in my calculator. What is the probability that the sample mean score for an SRS simple random sample of 15 will be greater than 600? So, is this the one where you do 600 minus 542 over 31.123?
Mm-hmm.
Yes. Okay. 600 minus 542.3 divided by. But we have to do the whole thing, the whole number. Remember when we did that last time? We both kept getting different answers.
Oh yeah.
It was so dumb. I was like, I'm so frustrated. Can't figure this out. Okay, 542.3. So 57 divided by 31.123.
Oh my gosh, my face is itchy.
That's unfortunate.
I know.
Did you get 1.854?
Uh-huh. And then what do you do?
You plug it into the normal probability output.
Mm-hmm.
Okay. 1.854 and above. So that's all. So it's 0.32.
Yeah.
Dude. That was awesome. You rock. Thanks for helping me with that.
Yeah. Oh my gosh.
Forget to put it in the probability applet. That's probably where I go wrong most of the time, actually.
Oh my gosh. Don't do that because you have the right answer.
I know.
You just need to plug it in.
I probably have I'll do the math and then I'll like plug in my answer.
Mhm.
And I'll be like, what? And then that one time you're like, yeah, just plug it into the probability applet. And I was like, oh, what? But anyways, cool beans. Oh, I guess I should submit that, huh?
Yeah.
Go to.
We did it though. We got 100.
Did we?
Yeah.
Woo! Are you ready for the exam?
I thought I was ready, but those like sample things, those trick me. I don't know why.
The very first questions, like the
Yes. Like the sampling methods. I don't know. I guess I just
would
need to read
just
them a little bit slower.
yeah, I would memorize the go right here and can you not see my screen anymore?
No.
Let me just do that.
And then we can have one sheet of notes, right?
Yes. I would just go right here on the lesson 2 recap that's in the lesson 8, whatever.
Like sample thing.
And like read these because this is how I found the answer to all those like cluster is all the items in a random. So like that's like one key thing is like just find keywords,
Okay.
remember them.
Yeah. Oh my
Like
god.
this one. That's you remembered stratified is like each group.
Smaller groups and then take a sample, like random sample. Yeah.
Yeah.
I think that one I think you made clear.
Mm-hmm.
But it's just that cluster sample. I don't know.
I would just focus on the all. So like think about taking random samples of groups. So like, oh, I want this group. Oh, I want this group from all these groups, and then test everybody in those 2 groups.
Okay.
That's what cluster means.
Yeah.
So.
Oh goodness.
Anyways, I will put the link on
the discussion board thing.
Yep.
Okay. Sounds good. Well, good luck on your test.
Yeah, good luck to you too. We want to meet on Wednesday?
Yeah, Wednesday at 6, right?
Yes.
Okay. Sounds good then.
All right, good luck on your test.
Thank you. Bye.
Bye.